So exercise 7 is very different than what we've seen before. I strongly suggest you take a moment, read through the question stem, figure out what exactly you've been given, and take a stab at answering part A. So hopefully you've at least read through this on your own, but I'll read through it with you now. We have a study of 10,485 randomly selected Americans in this age range. So we have our N. This is the biggest N we've ever seen in a question. In 2000, found that with a 95% confidence, the true proportion of Americans that are overweight is between this and this. So we have our confidence level. They've given us some other information, like what year this was from, so we know it's 18 years outdated. They've told us what our population of interest is. It's this 30 to 39-year-old age range of Americans. And then this last little piece, that the true proportion is between this and this. So they're telling us P is somewhere between 0.179 and 0.193. So hopefully you're recognizing right now that they just gave us the 95% confidence interval for the real P is 0.179 to 0.193. So this is the opposite of everything we've been done previously, right? In every other question, we were looking for the confidence interval, and in this case, we've been given the confidence interval, and now we're asked some questions. So the first question asks us to find the point estimate for the true proportion. And remember, if we're talking about true proportion, that's P. And if we want to estimate that, we're going to use P hat, the sample value. So normally we calculate this as X over N. And what happens for a lot of students in class is they get very fixated on this formula. They go, okay, well, we know N. That's 10,485. And then they, out of desperation, look everywhere they can to find X, the number of Americans in this age bracket who are classified as overweight. And what happens most of the time, and if you did this on your own, then you might have done this, they just find this lovely value of 2,000 and they go, aha, great, which is actually a year. So that's crazy. That's not right. So it turns out that this whole formula doesn't help us in this particular situation because we're not given that X. We don't know the number in our sample that ended up being classified as overweight. So we're supposed to actually use the drawing I made on the last question for this. Remember that idea that our confidence interval, well, it's symmetric. We start with the P hat, and then we add a margin of error, and we subtract a margin of error. So there's a margin of error to either side of our P hat. And we know what the two different endpoints are, right? Because they gave us the confidence interval. And we just want to know what P hat is. And P hat is going to be smack dab in the middle because you added and subtracted the same amount, right? And this all comes down to the fact that our P hat, our sample proportion, follows an approximate normal, which is a symmetric distribution. So how do we find the exact middle of 2 points? Well, we just take them and average them. So our point estimate for all of our symmetric confidence intervals is going to be the upper value plus the lower value divided by 2. Basically average out those two values. So 193, 179 all over 2, you get 0.186, which is directly between the two. And this is one that if you did not bust out your calculator, I strongly suggest you do, because a lot of students have a typo when they do this problem. So I'll bring out my calculator and show you what you might have to do. A lot of students will type this into their calculator as 0.193 plus 0.179 divided by 2. And they'll forget to put parentheses or do the numerator as a whole quantity first. So they'll give me out this is a value, which is not even between our upper and lower. So just be aware that if you want to do this all at once, that you need to be using parentheses around the numerator to make sure that you add them first before you divide by 2. The next piece asks you to find your margin of error. Once you have p hat, that's straightforward. You just need to figure out how much you added or subtracted to get to the other side. But if I asked you just straight up for a margin of error without finding the point estimate first on an exam, the easiest way to do this is to just realize that when we find our upper and lower, oh, this is not erasing. When we're looking at our upper and lower, bloop, bloop, we can see that the entire range, right, the entire width of this confidence interval is one margin of error plus another margin of error. So we can actually just do this as the range. So how far did our confidence interval span? And then divide by 2, because we want half of that. We had 2 different margins of error that were added together. So you'll get your 0.007 that you need to add or subtract. So if I had written this out, this would be upper minus lower versus upper plus lower. And this is something you may want to consider putting on your note card, because I always put some question here about like recognizing that if we have the interval, we can kind of go backwards to figure out exactly what the different components were of that interval.